Here is 8.2, exponential equations and inequalities. What you have is two exponent expressions equal to each other. And as long as you have bases that are the same, then we can basically eliminate those bases, set the exponents equal to each other, and you can solve the equation that you have left. Sometimes we have something as simple as this, where x is equal to 5. We can also do that in an inequality form, where these two bases are the exact same. Drop those bases out, and we have x is greater than 6. So how else do we use that? In this case, when you look at it, you do not have the same base, but what you can ask yourself is there a way for me to get the base to be the same? I can go no lower than a base of 2, but I can see if I can express 8 as a power of 2, and what I come up with is 8 is 2 to what power? I need to keep this 3 because this is 8 to the power of 3. What I need to do is, how do I write 8 as a power of 2? What would be this exponent that would be the equivalent of 8? Well, 2 times 2 times 2, 2 to the third is 8. If I do 2 to the third, I get 8. So 2 to the x power, I've done nothing to this side. I'll just continue to bring down. So 2 to the third, which is 8, this is still my third power because I had 8 to the third power. And at that point, I have these bases the same. I do need to simplify my two exponents, so I multiply those exponents, and I have 2 to the 9th. And then I can drop my bases, and what I have is x to the 9th, or x equals 9, excuse me. Here, we can ask ourselves, can I get any lower than a base of 3 for these two expressions? No, but can I express 9 as a 3 to some power? Yes, that would be 3 to the second power. And I'm going to keep this exponent, the 2x minus 1. So I have 3 to the second power, and I'm going to keep this side, and then I can combine these. So I'll multiply these two exponents. So what I have is, dropping these bases which match, I have this 2 and the 2x minus 1, which I'm going to be multiplying, and I have my 6x. So I end up with 4x minus 2 is equal to 6x. And then I can finish solving, where I subtract 2 here, and I subtracted 4x over, which gives me 2x, and I have negative 2 left. So negative 2 equals 2x, and then I divide out this 2, and I get x equals negative 1. Inequalities work the same way. But if we look here, is there any way I can get 16 as a power of 8? Well, 16 is 2 times 8. That's not an exponent. And remember, we're working here as exponential expressions. So I'm sort of stuck. Is there something else, some other low base that I can express both of these as? And let's see. Well, I could do 2's. 8 is 2 to the third power, and 16 is 2 to the fourth power. And last year I had somebody say, well, you could do 16 as 4 to the second power, but I cannot do 8 as a power of 4. But I can do it as a power of 2. So we re-express these as powers of 2. And of course, this goes no lower. I've got 2 to the third, and then I need to multiply these two exponents. I can drop those bases out, and what I have here is I have to multiply these two. 4 times that 2x minus 3. I have this exponent of 3. Bases I've dropped out. And then I go about solving this inequality. I'm left with 8x minus 12. I can move my 12. I have 8x less than 15 from moving the 12. I can divide by 8. And I can either leave this as my fraction of 15 over 8, or I can have the decimal equivalent of 1.875. And something for you to see as well is I have this as a fraction. And this is kind of my clue here. I have this base of 2, so I know I kind of want to put this as a base of 2. And if I have this as a fraction, I want to put that as a base of 2, but since it is under 1, since it's a fraction, that should lead me to believe I'm going to have a negative fraction here. So 32 is 2 to the 5th power, but it's under 1, so that's 2 to the negative 5th power. So if you see a fraction, you go, oh, that'll be a negative exponent. So I have this 2, which is unchanged. I have this, which I make a power of 2. My hint over here was I have a base of 2. So can I make this a base of 2 to some power? Yep, 2 to the 5th. Oh, but it's a fraction, so I need to make it a negative 5th power. And then, of course, I can drop my bases out. I have x plus 2 is greater than negative 5, and I can solve that. Make it x is greater than negative 7. So when you see these fractions, this number here, can you make it this base and give it a negative exponent? And that tells you, oh, I had a fraction. All right, for roots other than a square root, when I'm going to be solving something that had x squared and I have to get rid of the squaring power, my opposite is to do the square root. What if it wasn't x squared? What if it was some other power, like say 2 to the 7th power? The opposite is for me to do a 7th root. So what this is called is the index of the radical. So I have a radical, just like this is a radical, but it was a square. There's an understood 2 here for the square root. I can have if this was b to the 3rd, I would have a 3rd root. I can have a b to the 4th, and I can have a 4th root. So my index here changes. That tells me how many exponents I'm kind of undoing. That's going to set me up for writing exponential functions. So let's just deal with 2 points. If I change from a point 0.6.4 to a point 3/100, how did I exponentially grow? And so my exponential equation is y equals a times b to the x power. This y is my new y value, which changed from my initial y value of a, and this b is how it grows, so that's kind of my growth constant. And then x is the change in x. So we're going to look at a change in x. So how does this fit in? All right, so here's my new y value. My initial y value was 6.4. We need to figure out what our growth constant is. And my change in x, it went from 0 to 3, so that's a change of 3. So I need to solve this equation. How did I get 15.625? Well, first I need to get b to the 3rd alone. I divided out 6.4. So 100 divided by 6.4 gave me 15.625. And here's where I need to get rid of the 3rd power. So I have done a 3rd root. I've already done a 3rd root here. So doing a 3rd root of b to the 3rd cancels it out and leaves me with only b. So if you were to type this into the calculator, which we will review, and do a 3rd root of 15.625, you get 2.5. And so rewriting that, we want an equation in terms of y and x. So I want my initial y value and then my growth constant, which we just found, 2.5, and put it in terms of x. So here's a problem. In 2000, the population of the city of Phoenix was 1,321,045. By 2007, it's estimated at 1,512,986. And we're going to write an exponential function. Okay, well, let's decipher this. Between 2000 and 2007, that is our change in x. Here's our initial y value, our initial population. Here's our new population, our new y value. So let's put that into our exponential equation. So our new y value, our initial y value, our change in x from 2000 to 7, that would be 7. And of course we'll solve this just as we did a moment ago. Get rid of this b to the 7th is the 7th root. We get 1.0196. So here is our original population. Here's the growth constant, and it's in terms of x. And so that is how we write an exponential function.